Hello, my name is James Martin, and this is my presentation on my research paper titled Blockchain Eliminates Identity Theft. Here is my thesis statement for my research paper. Blockchain technology offers us an alternative to the normal banking system free of identity theft issues. Blockchain incorporates a peer-to-peer transfer system for data transfer, making it extremely secure. The fact that Bitcoin has never been hacked shows the security blockchain offers. The only negatives of blockchain are the numerous illicit activities it is used for due to its anonymity. The bulk of my information for my first two prongs comes from Luke Conway in his article, Blockchain Explained. Luke Conway is an esteemed writer for Investopedia with numerous articles covering blockchain technologies. The information I got covering the illicit activities mentioned in my thesis comes from Ahmed D. and Maynard D. in their research review on the agenda titled The Dark Web as a Phenomenon. This was a paper done by two students of Melbourne University. This paper goes into great detail on the different illicit markets that utilize blockchain technology. I chose this topic because I have a deep interest in computer science and tech stuff in general. I especially am interested in the illicit markets and parts of the internet that are not as well known to the public. I am just fascinated by the fact that these things exist and there's little that can be done to prevent them. The main reason and purpose for me choosing this topic, though, would be to show how blockchain technology is the solution to identity theft through the elimination of centralized data centers. My main research question here would be, is blockchain really secure? So I dive pretty deep into this. There are several ways in which blockchain accounts for issues like security and trust. New blocks are first stored linearly and chronologically in order from when they're received. This means new blocks are always added to the end of the blockchain. This gives each block a position in the chain called a height. After a block is added to the blockchain, it is very difficult, if not almost impossible, to alter the content of the block due to the majority consensus required to do so. Once a block has been added to the blockchain, in order for it to be reversed or changed in any way, there must be a majority consensus from all the blockchain data users. This is due to the fact that each block contains its own hash along with the hash of new blocks before it, as well as the previously mentioned timestamp. Hash codes are created by a math function that turns digital information to a string of numbers and letters. If that information is edited in any way, the hash code changes as well. So this means that each block in the chain mathematically checks itself through the hash codes. If any information in the block is changed, then the hash code function will change as well. So let's create a hypothetical scenario and say a hacker wishes to alter the blockchain in order to steal people's Bitcoin. If they were to try to alter their own single copy, it would no longer align with the rest of the copies. This means when everyone has their systems cross-reference their copies against the rest, they would all easily see that one copy is standing out, which would be the hacker's version. This anomaly would immediately be casted away as illegitimate and would not alter the blockchain. In order for a hacker to successfully control the blockchain, they would have to control 51% of the copies of all the blockchain in order to create a consensus after altering their own copy. This type of hack would require an insurmountable amount of money, time, and knowledge. There is just no way someone would be able to gain a majority of 51% of the blockchain, especially when it comes to massive networks like Bitcoin. These massive networks have such large amounts of users, and the amount of money is so vast in the market that gaining 51% of that market is honestly just impossible, showing that further that blockchain is extremely secure and has almost no flaws in relation to identity theft. But let's continue with our hypothetical scenario. So let us continue with our hypothetical scenario from before and say a hacker does somehow manage to gain majority share of the blockchain. Even if a hacker were able to pull off such an impossible feat, it would end up being fruitless. This is due to the fact that such a massive hack would not go unnoticed by the network members. These network members would see such a drastic alterations in the blockchain and react accordingly. The appropriate response by the network members would be to fork off a new version of the chain they are currently using that has not been affected. This would ultimately cause the old, attacked version of the blockchain to plummet in value. In the end, this would make the cryptocurrency a worthless asset for the hacker, showing that blockchain is extremely secure and really has no loopholes when it comes to exploiting its networks. When it comes to my recommendations, this is what I have. Switching our current economy to cryptocurrencies like Bitcoin is my recommendation. Blockchain technologies offer a solution to the identity theft issue. Currently, our economy relies on government-operated banking systems, which are vulnerable to scammers due to the use of centralized data centers. Blockchain incorporates a peer-to-peer transfer system for data transfer, making it extremely secure. The fact that Bitcoin has never been attacked shows the security blockchain offers. It is clear that blockchain is a better alternative to banking that we are currently utilizing. It will just take the initial jump from big banks to get the ball rolling with blockchain technology. Once this is done, I believe that cryptocurrencies and other blockchain technologies will become the new norm for our society. Here I would like to just cover all of the different topics I mentioned in this paper, review them, and conclude my thoughts. Blockchain technology, from this picture we can see on the left, is a centralized banking system. We can see that data and money is all sent through the transfer by one centralized system. While on the right, blockchain uses a peer-to-peer technology that passes the data along from one node to another. Although blockchain seems complicated, and it definitely can be, it really is quite simple at its core. Blockchain is just a type of database. Blockchain differs from a normal centralized database through the way in which it stores its data. The storage structure for blockchain is that it collects information together in groups known as blocks that hold sets of information. These blocks are chained together, linking information, which gives us the name blockchain. This begs the question, though, where is this data stored and who stores it? Well, just like a database, blockchain needs a collection of computers to store its blockchain data. These computers are not under one roof. Each computer or group of computers linked in the blockchain is operated by a unique group of individuals. So, is blockchain really secure? We know that blockchain is extremely secure through its requirements that check itself through the peer-to-peer transfer system. The main reason we know that blockchain is secure is the fact that it requires a 51% majority for any changes to be made. If a hacker were to somehow gain the majority, then the users would still just abandon that chain and start anew, showing that there are practically no loopholes in hacking blockchain technology. When it comes to the dark side of blockchain, blockchain offers a solution to the identity theft issue, but they also bring their own problems with them. Ahmed D. and Maynard D. go into depth in the negative issues that the dark web brings to blockchain in their research review on the dark web titled "The Dark Web as a Phenomenon, a Review and Research Agenda," stating, while the majority of financial transactions are traceable to individuals or entities in the real world, the emergence of cryptocurrencies like Bitcoin has allowed for near-anonymity exchange of money. This anonymity use of money that Ahmed D. and Maynard D. are talking about has enabled cybercrime to take place as criminals are able to send money anonymously. They continue stating how this level of anonymity is achieved. This is achieved using blockchain, a distributed ledger which requires no central authority for verification of transactions. This decentralized or distributed form of currency complements the dark web's nature to supply funding for operations without attribution of the source. Blockchain technology has given way to complete anonymity, which has had some negative repercussions. The ability to transfer money online anonymously and quickly has given rise to numerous illegal markets on the dark web. These illegal markets that use blockchain have tainted it and brought blockchain into association with numerous illicit activities. In order for blockchain to fully succeed, the elimination of these dark markets and websites may be needed. In the end, blockchain is definitely a possible solution to the identity theft problem. The P2P data transfer system heavily mitigates the hackers and potential data that they can hack. Incorporating it into our daily lives may be happening in the near future. And here are my references.